Welcome to StackAware's Quantitative AI Risk Assessment and Treatment Register. I'm Walter Haydock, the founder of StackAware, and in this video, I'm going to talk through this document, explain how you can use it to measure and manage the AI, information security, and other risks impacting your organization. So just at a high level, this is a Google Doc that you can download and you can use it however you would like in accordance with the license provisions that we have on the README screen. There's also a note at the bottom that says anything in blue is meant to be edited. I would recommend not editing other cells because that could disrupt complex formula chains, but do as you see fit. Moving to the changelog section of the risk register, this is a pretty common thing to see in compliance documentation. It lays out the requirements that are addressed by this document. I've listed ISO 42001 and 27001 here, which are international standards for managing artificial intelligence and information security risk, respectively. There are many other compliance standards that you could incorporate or use for this risk register, SOC 2, high trust, what have you. And then we have the changelog, which is a historical record of all the changes made to the document. I specifically note that these are schema changes only because the way that StackAware uses this register is it is continuously updated for our clients using our backend. So the changes in risks will be stored there at the individual level, but any changes to the schema of the document will be stored here. If you move on to the definitions and notes section, this lists out several pieces of terminology that are relevant for this register. And basically, StackAware is using a version of the rapid risk audit method that was advocated by the experts in risk management, Hubbard and Searson, and they lay that out in their book here. And basically, this is a simple way to quantitatively depict the financial cost of risk. And this is a rather simplified method from a quantitative perspective. We'll talk more about what you can do if you're looking for Monte Carlo simulations and loss exceedance curves. That is a feature of this specific register. But for the most part, we're going to be using the rapid risk audit method because it is relatively easy to understand. All right, so the next stage or next step we're going to look at is the risk descriptions and treatment tab. So this has a set of columns here. It starts with the risk number. This is a unique identifier for a given risk. Description at a high level, the detail of what the underlying issues with this risk are, a recommendation from these are provided by StackAware for certain risks for our customers, and then applicable frameworks. We mentioned 42001, 27001. These are the specific Annex A controls that are mapped to this risk. We also have a reference ID here. So this reference ID, number one, if you go to the References tab, is number one here. It goes to an OpenAI article explaining how your data is used to improve model performance. So basically, this risk is unintended training using ChatGPT. And essentially, the issue is that if you're using certain versions of ChatGPT, the system will be training OpenAI's models on your data, which could lead to the reproduction of confidential information to third parties without a need to know. And that is the essence of the risk. We do have some assumptions here, not for these categories, but for things like mobile device loss. So if you go to the assumptions tab, look up assumption one, we'll say that endpoints have basically trivial integrity exposure factor because critical data is generally not stored as the sole copy on an individual endpoint. It's usually stored in a cloud storage application or repository. And while there are confidentiality and availability issues, generally you're not storing the master copy of key data on an individual endpoint. And then we also have some assumptions about likelihood of malware infection for a given mobile device, and that's based on some Imperva data. So if you want to cross-reference that, you can go back to the reference IDs here. Okay, so proceeding along in the risk descriptions and treatment side of things. You move on to the individual's organization and societal impacts. So these are required to be evaluated for ISO 42001, although they can certainly apply to other types of risks or compliance frameworks. But these look at both the individual, societal side of things when you're deploying AI systems, as well as the organizational impact. So these are all the bad or good things that could happen as a result of a certain risk or certain situation. And then if we look to the final section on the risk descriptions and treatment tab, you've got the risk treatment option, detail, effectiveness, owner, and treatment date. So these are ways to record how you're handling a certain risk. So this risk treatment option is mitigate. And the way we're doing that is requiring users to opt out of training using ChatGPT. We assess there's a 50% effectiveness to this risk treatment method because not everyone will do it. Maybe some folks will forget. And this is an administrative control, so it's not going to be perfectly effective. We assign the risk owner as being the product owner for this given system, and then we record the risk treatment decision date here. Okay, so that is the high-level overview of risks that we have in this register. If you move on to the calculation side of things, this is where we get much more fine-grained in terms of how we're calculating these risks. So for each risk, we have applied that to a given asset. Again, these are just example assets here. And what we're looking at is we are observing the confidentiality, integrity, and availability exposure factors. So for certain types of risks, integrity, like I mentioned, is not going to be an issue. So for the data on an individual endpoint, we're not too worried about the integrity being corrupted if there is an event where the data is destroyed on the device, because we're assuming that the data is going to be stored in another form, a cloud repository, something like that. Then we're going to move on to the confidentiality, integrity, and availability rates of occurrence here. These are how many times in a given year we expect a certain event to happen. These can be developed from research, from prior experience. You can make assumptions about how frequently these are going to happen, but record these here. And then you'll log the risk treatment effectiveness of a given control. So, for the risk for ChatGPT unintended training, we said that it was 50%. Then you've got a series of calculations. These are pulled from other tabs, so I'll go into those in depth in a moment, but don't modify these because these are complex formulas that chain through multiple different tabs. But if you go all the way over to the right, you can see the inherent annual loss expectancy and then the residual annual loss expectancy for each risk. So this looks at the risk without any sort of treatment, and then this one looks at the risk with the treatment. And you can sum these all up into total organizational risk. Now, this is rounded off because we don't want to imply that we have such a high degree of confidence or certainty in our risk calculations here. But this is the sum of all of the residual risks for a given organization. So this tells you how much risk you are taking on. So we talked about the exposure factor, and we also talked about the annual rate of occurrence, and that is part of the equation. But another part of the equation is the data valuation that could potentially be impacted by the risk. So we calculate that through a variety of ways. We look at company attributes. So, for example, the mean annual salary, the mean annual salary of people responding to information security incidents, and then the minutes worked per year, as well as the revenue for the organization are all taken into account for making calculations about the impact of a given risk materializing. The next tab that we're going to look at is the Data Valuations Dictionary. And this lays out a whole different set of definitions for a variety of fields that are available in the next tab. But basically, it says what each one means at a high level. So we'll go through this now. So if you look at the Data Valuations tab, you're looking at individual assets, and then you're looking at a variety of assumptions, or calculations we made about various characteristics that are related to the risk posed by a given event occurring. So, for example, for a laptop, we're assuming that recovery time is 30 minutes at the lower bound, 120 minutes at the upper bound for an event that requires recovery of that asset. So that would include things like, re-imaging a device, maybe even the time it takes to get someone a new one in an office scenario. We're looking at revenue loss per minute for a given device. That's based on the individuals who are using that device, the criticality of the processes that they are working on. We'll look at competitive advantage. We'll look at external response costs, crisis communications, legal costs, ransom if you're potentially in a ransomware scenario, replacement costs. We're looking at regulatory impacts, HIPAA fines, GLBA, EU AI Act, CCPA, going all the way down to looking at reputation damage from an event occurring, as well as changes to insurance premiums. So there's a whole array of different factors that go into calculating the risk from a given scenario materializing. And then if you go to the impact calculations tab, this is essentially looking at the data valuations and then doing some math based on the risk quantification factors, which is essentially how much each attribute of the confidentiality, integrity, availability triad impacts data or impacts your risk. So basically we're saying that there's zero productivity loss from impacts to confidentiality, but there is productivity loss to impacts from integrity and availability. And then conversely, there are if you're talking about reputation damage from downtime, that's not a factor of loss of confidentiality. It's a factor of loss of data integrity or availability. And then conversely, if you're talking about reputation damage from a data breach, that all derives from loss of confidentiality of information, not so much integrity or availability. So that's what the impact calculations tab is doing for you. Okay, and then to wrap up, for those of you who are purists who might say that a simple number from a risk calculation is an oversimplification, well, the good news is that StackAware's risk register does provide you the option to build a loss exceedance curve doing a Monte Carlo simulation. So if we wanted to pick a specific risk, we picked risk number 9. And if we go back to our relevant tab here, we see that it is data retention risk using ChatGPT. Again, this is just for example purposes only. But what you can do is you can build a loss exceedance curve, which tells you on the y-axis, this is the chance of a loss at a certain dollar value occurring or greater. And then you can see the loss dollar figures on the x-axis of this chart. So basically it says, we're looking at, this is 500,000 right here. So we're saying there's a 1% chance of a $500,000 loss from this specific risk over a given year. And this is built from a series of simulations that are done. We do 1,000 simulations for each event to help build this loss exceedance curve. Now, explaining exactly how Monte Carlo simulations work is probably beyond the scope of this video, but I strongly recommend that you look at the Hubbard and Searson book, How to Measure Anything in Cybersecurity Risk, to understand how to effectively use Monte Carlo simulations. All right, well, thank you for taking the time to review StackAware's risk assessment and treatment register. And I hope that you find this video and the template helpful in building and maintaining your artificial intelligence and information security risk management programs.